Hello everyone, this is the next session on the network packet analysis. Today we will learn how to identify malware activity with network packets with Wireshark. We'll wait for a few minutes and then we'll start.
If you are
If you are
unable to
unable
hear
to
my
hear my
voice
voice
properly,
properly,
or if
or
you are if you are
if you are
listening any
listening any
disturbance,
disturbance,
please
please
let me
let me
know
know
so I
so I
can
can
make
make
the
the
required
required
changes
changes
before we
before we
start.
start. Okay, let me try to change the headphones and then see if we can hear me properly now. I think now you can hear my voice properly, and if you see any disturbance in the voice, please let me know in the between also I can make the required changes. Okay, thank you all for joining today in the session of malware hunting with network packets. In the previous sessions, we have also discussed about the same, but in the general terms, like how a Wireshark tool used in the network packet analysis, what are the different informations we can look for, and how we can identify anomalies in the network packet based on the comparisons with the snort signatures, and then the difference between the manual analysis. We will continue the session now, and we will look for the another packet number 2, and let's see what other difference we can see when we had done the same thing, same kind of analysis within IDS solution snort. So I have two packets now, second.pcap and attack.pcap. First, I will open this second one first file, second.pcap. Last time when we had checked this packet against the IDS snort, we have seen this snort IDS trigger different signatures related to the ICMP scanning and some SMB violation. Now, let me recap that same thing if you are new or if you recently joined our channel. So it will be help you to understand how a network packet first check within comparison to the signatures of the malicious packets or malicious content, and then we can identify the anomalies based on the manual analysis. So I'm opening this second window where we have already installed snort, and then we will run this packet in the reply nature to see what other signatures have been triggered by the snort. So we have installed this snort as an IDS in our C directory. So I'm just changing my directory to the cd snort. We are running in a snort in a CLI mode, so we have to go to the same directory where we have installed the snort application, so we can give the required arguments and parameters to run the snort against our network packet. Now we will use the term snort syntax, and we have to define the configuration file which is present in the another same C directory. -c is used for defining the configuration file, c snort etc snort.conf, and to read a packet with the comparatively with the network IDS solution, you have to use the argument -r and the packet name. So we are running this snort database against this packet 2.pcap, and we want the output on the console, so we'll use the capital A and the console. So we want to run snort in the quiet mode, so we can use the -q option. Now snort will run, and snort will compare all the signatures, enabled signatures against this network packet contains, and let's see what other signatures, what different signatures snort will trigger based on the content identified in this network packet. And then we will do the manual analysis for this packet capture to see what other gaps have been we have seen which did not trigger with snort, but we identified through manual. You can say there's so many signatures triggered for this packet, and if we go up, I think we cannot go up like till it started because it will show the length of the particular buffer. So we have to let me check other signatures. So most of the signatures are usually triggered for the ICMP text, because in this note we have enabled our rule which will trigger on every ICMP request. If it contains in a packet, sort will trigger one signature for that. Apart from this ICMP signature, we can see another signature related to the OS, Windows, Microsoft Windows upgrade limit ICMP integer overflow explorer attempts. Again, based on the, I believe, high amount of ICMP traffic identified in the network packet, and this second signature is triggering. Again, the third signature is for again ICMP text coming down. Okay, the next signature triggered by this not IDS is for policy violation regarding the SMB protocol. So initially I mentioned when you are doing the analysis with the network packets, you should have a good understanding the basic fundamentals with clear about the different protocols, services and ports. So if you don't know about SMB protocol, SMB is several message block protocol used for file sharing, and also when we are accessing the different file resources present in a different machine in Windows, the SMB protocol is used. For example, if you have shared a particular file in your machine with other machines in the network, those machines access the particular file with SMB protocol. So if you have in your company, in your home, if you're accessing any shared drive, that actually works on SMB protocol, and the port number is 445. This all different protocols, port services we already have covered in our book Hunt the Hackers, a complete SOC analyst guide, and which we have completely defined about different protocols, attacks, scenarios. And in this video, we will learn how we can identify the malware activity with the network packet analysis. So we have seen the signatures triggered by this node because it might be a packet. Network packets have different sessions, different protocols, and it might will take a lot of time for you to investigate. And if you are not known about different protocols, you might miss something. So whenever we are new or we are starting our understanding with the network packets, we start building our concepts, then we have to first compare the activity, the threads with a particular IDS or IP solution, and then we can dig into the packet with the manual analysis. So we have seen two things we have triggered by this node, one for the ICMP, second for the SMP. And we have also seen another signature for again for the SMB session setup for NTLM SSP Unicode overflow attempt. We can also run a search for the signatures on the internet to see what is the signature about and how snot are actually capturing and what contents they're looking for. And also we can also look in our snot signature database to see what contents have been defined for this particular signature to see how it is behaving and how it is capturing the network packets of threads. Okay, so mostly we have understood that this snot identified two types of behavior and based on threads. One is related to the SMB and second for the ICMP. Now let me open this node. Now I will open the packet capture with the Wireshark tool, which is a network analyzer tool, and we'll decode the network packet and see what information, if we can see if there is any other information which missed or which might not be available in the terms of signature with this our ID solution. Okay, so I have opened that file to.pcap in the Wireshark, and when you are referring to any particular packet file, you can see how many packets it has. So it has 1700 packets. If I would ask you to do manual analysis on this packet captures, then it might take a lot of time for you to understand if you are going to one by one packet or one by one session. So it's better to go to the statistics and to see general information about this packet, a brief summary about this packet protocols, endpoints, conversations, byte transferred, how many packets sent. So we can now directly go to the protocol hierarchy to understand what protocols communication have been captured in this network packet. So we can see the ARP protocol, we can see the ICMP protocol. There are more than 1000 packets captured for this ARP, and total packets we can see is around 17,000, and 1000 packets is only for the ICMP, 600 packet for the ARP protocol, 1400 packet for the TCP, 1300 for the 14,000 packet for the TCP, and 1300 for the UDP, and we also have 3 packets for the ICA version 6. In UDP, we can see what other protocols were communicated or sent forward and received by this machine, or what other communications have been captured in this network packet. We can see the protocols. Other protocols is for the DNS, DTLS, multicast, domain name systems, port mapping, NetBIOS, Radius, RPC, SNDP. So there are different protocols have been captured in this network file. And if you are not good in the investigation and analysis, or you don't have the understanding about these different protocols, then you will not build a picture what actually going in this network packet. So it is very important for you to first understand about these protocol and services, what is the purpose of it is to be used in the network. For example, let's take a simple scenario, DNS. If you don't know how DNS work, what protocol DNS uses, what port it used, and what is how you can identify abnormalities and normal behavior with the DNS protocol, you cannot identify, you cannot investigate the malware activity. So first you have to build your basics with your different understanding about different protocols, ports and services. Then you can come to the network packet analysis once you have built your complete understanding about different protocols. In TCP, we can see other communications related to the different protocols, SMB, NetBIOS, and DCE RPC protocol. Also, okay, now I'm closing this window and opening the other endpoints. Let's see how many IP addresses have been captured in this network packets. So there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 IP addresses, and you can see the connection between these 8 IP addresses if you will click onto the conversation window. You can see that now packets address A and address B. You can see how many packets sent by the address A to B, B to A, and the time and the packet size and the bytes. This is first important to understand what are the IP addresses which are communicating most. So we can see the IP address which is communicating most is between these 4 IP addresses, 10.1.5.2 and this 73.135. Now if you will go back to this note to see the signature attempt and the information present in that particular signatures, you can find out the attacker IP address. So first you can see this attempt, go to the hub, you can see the ICMP text, all traffic are going to this IP address 73.135 from 73.10. Again 73.1 sending packet to the 73.135. So we are seeing multiple IP address sending ping request message to 73.135 IP address. It could be multiple IP addresses are compromised and targeting a single IP address, or this could be the response packet for the ICMP. Now if you go back to the network packet to see the behavior for the ICMP packet, now you can see the destination unreachable, and we can see the connection between 73.10 to 73.135. Let me check if there is any other IP address as well. Okay, now you can see there's one more IP address 73.1 sending destination unreachable message with ICMP protocol to IP address of 73.135, and then another IP address came 73.10. Let me come down. Okay, now this is the questions to my all viewers. If they can tell me why these destination unreachable messages are being sent by this source IP addresses to the destination IP address. Okay, if you remember that in the last session we had discussed the same, that when attacker send a UDP packet, that machine, if running with the particular port number, that will send a response if the port is closed with the ICMP protocol. For example, if attacker is sending a port scanning traffic for UDP ports to the destination will reply with the ICMP response packet and will see the message that the port is unreachable. Now if we go back, or if we check in this response header below, you can identify what are the ports targeted by the attacker. So we can see now the attackers. Okay, now you can see the UDP protocol. It is a packet number, source port 43078 and destination port 19719. Now if let me click on different packet, you can see the packet is keep changing for the destination port numbers, but source port is static. 137, 18,000, 30,000, 17,000, 1,000. So this attacker 192.168.73.135 was running a port scanning attack traffic towards the internal IP address, and we can see the port is closed. That is the reason this source IP address sending ICMP response. Now let me delete the ICMP and look for other different protocols and headers information. So we have ICMP. We can also see some TCP reset packet, different port numbers. This is again a port scanning attack, OTC protocol. If I will select filter the traffic based on the IP address, IP header equal to 192.168.73.135. So it will show you the both the communication with the source and destinations. If you are not good in the display filter, you can go directly to the details pane, go to that IP address, and you can select that IP address based on which criteria you want to look for. For example, if you want to select as a for particular source IP address, you can do this. For example, clicking on this, it will select ip.source equal to that IP address. Now you can change the IP address 135. So you can see now the connections from the same attacker IP address, and all are sent with SYN flag because to the process of three-way handshake, and the target port are keep changing. So this IP address is doing port scanning attack to the IP address on both protocol, TCP or UDP. All are the same packets in request on multiple destination port, and the same logs. This is the network packet. When we are in the corporate companies, working as SOC analyst or SOC team, we can see this kind of traffic on the firewall, and the firewall will show you the connection from the IP address and destination IP address and targeted port numbers. So from that you can consider it to build a rule or logic for the detection of port scanning attack. So we have seen the two patterns. One is for the UDP port scanning and second is for the TCP port scanning. Now I'm looking for other different pattern. This is the ARP request message. You can see this is the ARP request, is the ARP response. So when a machine joins the network, it sends the ARP request to know the MAC address of the other machines. So this is the first is the ARP request and second is the ARP response message from the destination. We can look for the destination DNS resolution also by clicking on the resolved address. This is rolling based on the MAC addresses and the port numbers. and if it resolved particular DNS name as well, it also stored it there. You can see this is the all DNS requests sent for the particular domain name. DNS query. This is for the SOA record. Generally, client does not send the SOA request. Now we can look for the connection over the SMB protocol. We can see this is the SMB connection. SMB connection was requested by the attacker IP address, or no, this is other two internal IP address. We are expecting this is that attacker IP address 192.168.73.135. This is the other IP address in the network 73.10 and 73.5. This is the general connection for the sharing or accessing the file. We can see this is the request sent by this IP address, or might be if attacker have compromised other machines, other machine can also be used as a pivot or lateral movement to compromise other machines in the network. And we have seen the pattern where the IDS signature identify an attempt through the SMB protocol. Now I will show you how to actually identify an attacker based on a real compromised traffic network packets captured. So let's see what information we can extract from that. I'm using another file attack.pkf. Now I will do the same thing what I did with the second pkf file, second.pkf, and let's see what signatures it will trigger by this nodes, and then we will do the manual analysis with the network packet on Wireshark. Let me first clear the screen. CLS. Packet file name. Give the result for the console. These sessions are for you to understanding why network packets are important, and we will see in our next session how device logs are important when we don't have the visibility in the network packets, how we network device logs or device logs generated by different devices like Windows, Linux, router switches, how they critical are for us for the investigation. Network packets are used for the communications, but any activity done on the machine will be more visible when you check the logs for the particular device. So now we can see there are not much ICMP traffic, but yes, there are some specific signature triggered by this node for the again SMB protocol, and we can see the anonymous connection also for the SMB. Anonymous connection was allowed in the Microsoft operating systems to connect between two different machines for accessing some internal communication process, but which later have been restricted by the Windows to allow only if you are authenticated already in the network with an account. Previously, it can be done without any authentication. Then we can look for the other thread signatures. We can also see the signature related to the particular malware file. A network Trojan was detected. So we can see Snort have also triggered a signature for a particular Trojan file. And we can see the IP address is 98.114.205.102. To the IP address 192.150.11 and .111 and port 445. Again, in this attack, target one services is SMB. and it also giving the information about the port number. Source port of the device is 1248, 1228, and the destination port is 405. So we can look particular session based on the Wireshark analysis. Now I would have I would like to ask some different questions before we investigate so we can all understand about the investigation of the network packet. So first, the question is to identify the involved endpoints in this network packet. We can go to the statistics and click on the endpoints. You can see there are two machines involved. One is the 98.114.205.102 and second is for 192.150.11.111. Only the connections, the captured packet between these two IP addresses. And we can see the packet captures are for the packets this 348 183,000 bytes transferred. You can see most of the connection is only for the TCP, no UDP packet observed. Now if I will go to the statistic protocol hierarchy, we can see the connection is only based on the TCP protocol. We can see the NetBIOS protocol in the NetBIOS SMB. Now let me open the network packet. Okay. When we are investigating a TCP packet or UDP packet, we have to first understand the requirement, what is the approach we are using. So might be attacker machine originated different session to the target, and we have to understand the traffic flow within network packets, and then might be if we have the logs available with us, we can check the logs of the device to identify the attacker activity. So first, if you will ask me to look for the different session, I will click on a first packet, click on follow and TCP stream. Close this. You will see this is the sequence of first session. If I will change the 0 to 1, this is the second session, third session, fourth session, fifth session. So attacker has initiated only 5 sessions to the between the compromised and attacker machine, because we have started from 0. In this session, what information you can look for, you can see the attacker actually first send a SYN packet on TCP protocol towards port 405. Packet machine send a response with the SYN plus ACK packet, then third acknowledgement packet, and then finish and acknowledgement by the attacker machine. That means attacker was checking if the port is open or closed. Now let me go to the second session. In this session, attacker attempted to connect on the shared servers or shared repository by SMA protocol, and had attempted to null session as well, as we have seen in the snort signature. If we look for this particular thread signature by the IDS, it shows us that attacker had attempted to Windows Microsoft SMB anonymous session IPCCL. So for example, if I will look for this particular thread, I can copy this and can search on the internet. SMB anonymous session. You can read about these blogs to understand about the behavior of these sessions and how dangerous it could be. So attacker use these SMB connections to enumerate the user accounts, enumerate the groups and information, so they can connect and can copy the files if it is by default admin shares are present on the machine. So now if we go back to our network packet capture, we can see this is the negotiation protocol request by the client and the server, and they connected again to this IPC share. And then we can see some other connections related to the RPC protocol, and something happened here regarding the DS role upgrade down level server. And if you will go back to this network packet, you can see there are some attempts related to the DS role upgrade down level server overflow attempt. So attacker attempted to exploit the vulnerability in the machine, which is for the attempt administrated privilege gain. That means attacker want to gain admin privileges and attempting to explore the vulnerability in the machine. We will not go in detail of each header in the packet for the SMB, but for you it is important to understand how attacker is targeting and what you can see in the network packets, and how can you use those network packets and the IP signatures to compare and identify attacker activity in the network. So we have seen that attacker first attempted to connect it with the session, then attacker attempted also for to gain admin privileges. Let's see where we can see this network Trojan file in the network packet. I'm going back to the network packets. Sequence number 2. Okay, there's some other packets. TCP communication, and we can see if there is any data or no. TCP data. There is some information. We can also look for the information in the hexadecimal format. For example, if we click on the data, you can see some information. Okay, you can see there is some file presents as ssms.exe, some executable file transfer. Let me go up. Okay, there is also one command. We can see echo open IP address, port number, reduction, and some command. If it is not clear to you, you can directly click on this any packet, click follow on TCP stream. Wireshark will do this for you by reconstructing the network packets. So we can see the attacker actually, after exploiting the vulnerability, attempted to open a port on the machine and try to get this file ssms.exe through FTP servers and delete that file. Now let me check for the next session. Now if we directly go and click on the follow TCP stream, you can see the FTP connections from the machine, and you will see the file retransmit successfully from the attacker to the target machine. And this is the file which possibly triggered that Trojan file connection. You can also look for other information if it is present somewhere. So Wireshark is doing a very good constructive packets, so you can understand and you can identify the intrusion entry by an attacker machine. The next information which I will present to you is very important, and might be when we will have the more live viewers on the channel, then I will show you how we can extract the actual payload or the file from the network packets through Wireshark and other different tools, and how we can identify if that file is actually a malware and what type of the malware it is. This is all for today class. Thank you for watching this session.